Chapter 8 starts to kind of combine some of the things that we've talked about in previous chapters and look specifically at pollution policy. How do we decide what is most effective in different industries and with different pollutants? So it's sort of summed up. If we had all the information, then there's a clear optimal level of pollution, right? And we've discussed before that it seems odd to talk about an optimal level of pollution when it seems like zero pollution would be ideal, but that's not necessarily the case because if you consider the benefits of production, and you can't have production without some waste or pollution, and so there is some optimal level of pollution that balances the marginal cost of reducing pollution with the marginal damages of pollution. So that's what's shown here in this type of graph. Um, we show, so the maximum level of pollution is shown down here on the right hand side, and the marginal cost of reducing pollution, you notice, grows as we reduce further. So as we get closer to zero pollution, the marginal cost of reducing pollution gets steeper and steeper and tall and higher, um, while at the same time the marginal damages of pollution get lower as we reduce pollution. So um, you can think about this left to right or right to left. So right to left, you can think about the marginal damages of pollution growing as we have more pollution. And the marginal cost of reducing pollution falls as we are allowed to have more pollution. But anyway, so there's this optimal level of pollution is at the intersection of those two curves, where the marginal damages of pollution are equal to the marginal cost of reducing pollution. Because you will notice that anywhere to the right of that point, any higher level of pollution, the marginal damages of pollution are higher than the marginal cost of reducing it. And so we would benefit by reducing it. It costs us less to reduce pollution at this point than than the cost on society if we don't reduce pollution. So in other words, the marginal benefit of reducing it is higher than the marginal cost of reducing it. And anywhere to the left of that optimal point, we have the opposite situation where the marginal damages to society are pretty low relative to the marginal cost of cleaning up the pollution. So it actually would cost a lot more to reduce pollution at this point than it's quote unquote worth, than the benefits to society because the damages are so low. So the optimal point then is the point right where those two intersect, because we can see the argument that we don't want to be on the left or on the right of that point. So how do we get to that optimal point? One option, as we discussed when we were talking about externalities, is a tax. So if we look at the marginal cost of reducing pollution as a curve here on the graph, where again the maximum quantity of pollution is down here on the right, and we think about setting a tax, right? So if we set a tax equal to T1, then the firm will have an incentive to reduce pollution to the point of Q1, to the point where their marginal cost of reducing pollution is lower than the tax, right? So as long as the cost of reducing pollution is lower than the tax you have to pay to produce or to pollute, then clearly it costs you less to just reduce pollution than to keep polluting and pay the tax, right? But with that tax of T1, if we kept reducing pollution to the left, further to the left of Q1, if we were going lower and lower in pollution, notice the cost of cleaning up is higher than the cost of just paying the tax. So anywhere to the left of that, they would just choose to pay the tax and still pollute, because the cost of cleaning up the pollution is higher than the cost of just paying the tax. So a tax of T1 would give the firm incentive to clean up to the point of Q1. So a higher tax, of course, would be incentive to clean up even further. So a tax of T2, they'd have incentive to clean up to the point of Q2, but no further, because further than that, the cost of cleanup is higher than the cost of just paying the tax. So that's how the tax works. Another option is tradable pollution permits, and we've looked at this a little bit in a previous chapter as well. This graph, which looks kind of busy, I know, sort of sums up what will happen with tradable pollution permits. So you can read more about how this exactly works, but the summary is that we decide as a society or as an area, as a region, how much pollution we want to allow. Say 20 units of pollution or 40 units of pollution, we divide that between the two factories that exist in our region. And so we say to each factory, you can pollute 20 units and you can pollute 20 units, right? If we do that, then where they will end up on this graph is right here at the initial allocation point. So the way to read this graph, notice we've got two firms, and we have their marginal cost of reducing pollution represented here. One of them, firm one, will read from right to left, from left to right, and firm two will read right to left. So notice you have two different axes here. So firm one, the level of zero pollution is over here in the left hand bottom corner, and firm two, the level of zero pollution is over in the right hand bottom corner. So firm two is cleaning up pollution if we go toward the right, toward the left, and firm one is cleaning up pollution if we go toward the right. So that's how we read this graph. The marginal cost of reduction for each of them gets higher and higher the more they have to clean up, right? So the initial allocation is, let's give each of them 20 units of pollution, so they'll be here at this dotted line where each of them has 20, will pollute 20 units. The marginal cost for firm one is $200 at that point. The marginal cost for firm two is $600 at that point. So the total cost that firm two is spending on reducing their pollution down to the level of 20, from where they were before, is this entire triangle. So D plus B plus C is what they're having to pay in order to reduce pollution by 20 units. And firm one is having to pay the triangle A, all of the area below their marginal cost curve is what they're having to pay to reduce pollution. So, and notice for firm one, the cost of reducing pollution is much lower than for firm two, and that may have to do with the size of the firm or the technology available or different things like that. So, so it works to get us below that 40 units of pollution allocation or goal if we allocate them 20 and 20, but it's not necessarily efficient. What would work better is if, here, each of you has 20, now you're allowed to trade. You're allowed to sell to each other. Now what's going to happen is, since firm one is able to clean up much more cheaply, at much more cost effectively, the cost of cleaning up is lower for firm one than it is for firm two, they'll trade. Firm one will say, all right, we can reduce our level of pollution more cheaply than you guys can, so we'll reduce all the way up to 30 and sell you the other 10, right? So what ends up happening is we end up getting to this, the point where the two marginal cost of reduction curves intersect. And the reason here is very similar to what we talked about a couple of slides ago in that optimal level of pollution slide. And that is that at the place where they intersect is where their cost of reduction or marginal cost of reduction is equal. Anywhere to the left of that, the marginal cost of reduction for firm two is much higher than the marginal cost of reduction for firm one, meaning that firm one can keep reducing and sell the rights to that extra pollution to firm two for something that firm two is willing to pay, because it's cheaper for them to buy those extra rights to pollution than it is for them to clean up. So anywhere between, so back to here where we actually have the numbers, if they both have 20 units of pollution, firm two is willing to pay up to $600 to be able to pollute a little bit more because it costs them $600 to reduce pollution. So anything less than that they can pay for another unit of pollution, they'll pay. And firm 2 is willing to accept anything above $200 because it only costs them $200 to reduce their pollution a little bit more. So sure, we'll reduce by one more unit so that you can have that unit, and we'll sell you that unit for any price between what we're willing to accept of 200 and what you're willing to pay of 600. So all the way in this area up here, this triangle D, there is gain from trade where firm 2 is willing to pay something in order to not have to keep cleaning up their pollution, because cleaning up their pollution is really expensive. And firm 1 is willing to accept something in order to keep cleaning up, because cleaning up is not all that expensive. They're willing to sell their pollution to someone else and clean up. So until we get to the point where the two marginal cost curves cross, there's benefit from trading. And to the right of that point, the benefit is no longer there because now the marginal cost of continuing to clean up for firm 1 is higher than the marginal cost for firm 2. So there won't be a benefit in trade. When we're thinking about pollution policy, the book continues to go through. So they first talk about those two sort of options. There's the tax option, and then there's the tradable pollution units option. There also are other options like just uh, technology options, so the government just mandating you must use certain technology, or just mandating you cannot pollute past a certain threshold with or without the trade option. You can read more about those, but of course which policy you choose depends on what pollutants you're talking about and what the damages look like. So there's a variety of different pollutants, and what they do and how they act and what the damages from those pollutants look like is different, and so that will dictate what policy works the best. So some pollutants have a linear damage effect. Those are most of the ones we look at just because that's the sort of easier model to analyze, but it just says that the more you pollute, the more damage, and that goes up at a pretty constant rate depending on how much pollution. There are others that have a threshold where below that threshold the damage is pretty low, but beyond that threshold the damage skyrockets. So a pollutant with a nonlinear damage effect. And again, what pollutant we're talking about and what the effects are will certainly dictate what policy works. And then there are other pollutants that have a concentration issue where it's not just something that goes into the environment and sort of dissipates and is gone pretty quickly, but the more you pollute, the more it sort of accumulates and becomes a more concentrated pollutant in the atmosphere or in the environment. And so reducing emissions or freezing emissions doesn't necessarily do the job super quickly, right? So you can see the relationship between the top graph, which is the amount of emissions, versus the bottom graph, which is the concentration of the pollutant in the environment. So as we're increasing emissions, the um, the concentration in the environment also is increasing. But even here, where we freeze emissions and we don't allow any additional growth in emissions, we're still seeing growth in the concentration in the environment. And the only way to start to have the concentration in the environment come back down is to actually stop emissions, because as long as we're still emitting, still polluting, we're still seeing growth in that concentration that exists. So again, these are just discussions that have to go on when we're thinking about pollution policy and pollution control. What kind of pollutant are we dealing with, and what are the effects, and how are those effects accumulating, or are they just dissipating? Um, And then, of course, as with most policy, there's a lot of uncertainty. So we saw the very first slide that I popped up here showed that the optimal level of pollution is where the marginal damages curve and the marginal cost of reduction curve cross, right? The problem is we don't necessarily always know exactly what the marginal damages or marginal cost of reduction curves look like. And so we can't always pick that optimal level of pollution. If we could, then do it. Then just do it with the tradable permits or do it with a tax and get there and perfect. Boom. But a lot of times we're guessing about these things, and what we guess will have a big impact on how efficient our outcome is, right? So we may end up reducing pollution a bunch, but we also put such limitations on production that we actually reduce efficiency. We haven't found that happy uh, happy place where we've got our optimal level of pollution so that we still allow the benefits of production. Or the opposite may happen. We may um, be hesitant to reduce pollution too much. So we allow the production to happen, and then we end up with the other scenario where we're still not in an optimal place because the pollution levels are higher than what would be optimal. Um, but sometimes we do know some information. So, for example, look at this graph versus the next one. So if we happen to know, we don't know exactly what the marginal costs of reducing pollution are or exactly what the marginal damages are, but if we're pretty sure that the marginal cost curve is pretty shallow versus the marginal damage curve, which is steep, in other words, the marginal damages grow much faster than the marginal costs, then the policy that's more appropriate here is a policy that limits the level of pollution, not a tax policy. Because what's going to happen if marginal costs of pollution are pretty low, then more firms will choose just to pay the tax and continue to pollute. And so the damages, which increase much faster than the costs, the damages will be a lot higher wherever we end up. So it's a policy that's more effective to get us toward that optimal point would be a policy that limits the amount of pollution, because ultimately with a marginal cost of reduction curve that's so shallow, so low, um, the cost of cleaning up, the cost of reducing um, pollution is relatively low compared with the tax. On the other hand, some industries may show a really steep cost of reducing pollution. It may cost a lot to try to reduce pollution, and if it's the case that the marginal cost of reduction curve is a lot steeper than the marginal damages curve, as shown in this graph, then a better policy would be that tax policy. If the costs of reduction are really high, then a tax would be effective to convince people to reduce their pollution, um, versus versus the damages. So it may be that it actually is not cost effective, is not efficient for us to reduce pollution by a bunch. So if we required companies to reduce their pollution, in this case maybe from Qmax all the way down to Q1, then we're putting a much bigger burden on production than we're getting benefit in terms of the pollution damages. And so we're going further from what's efficient by forcing that reduction in production, or a reduction in pollution. Um, and so what's a more effective policy is the tax policy that allows the firm then to decide, maybe it's cheaper for me just to pay the tax but to keep producing. And in that sense, with such a low marginal damages curve, sure, maybe pollution stays at a slightly higher level, so the pollution in this case would stay at Q star, um, but the trade-off is worth it. The trade-off for the benefit we get from production is higher, is better than the sort of marginal benefit we would get from cleanup. And then, of course, all of this, those marginal cost of reduction curves can change with technological change, and that, of course, will change what effect a policy has. Um, any of these policies should encourage technological advancement. So you can stop paying the tax if you can figure out a new way to produce with lower emissions, right? If you have new technology, the amount that you're having to pay in tax can go down. So we should see marginal cost of reduction curves move to the left. So from the first one, marginal cost of reduction 1 toward marginal cost of reduction 2, and that'll have effects on what policy does too. And then I love this. This is in your book. Table 8.2 gives a nice summary of everything that's discussed. What types of policies are effective in what types of scenarios. Policy making is tough. There's no one size fits all solution. And as this chapter discusses, there's a lot of uncertainty. There's a lot that we don't know for sure about the costs or benefits of certain policies or even of pollution, for that matter. Um, and so it's kind of a lot of trial and error, and a lot of just doing the best we can with the information we have. And so this table is a really nice sort of summary of how we sort of analyze what's going on and pick the best policy solution.